Next up, we're going to hear from Dominic Williams, who is president of Dfinity. Dominic.
Hey. Thanks. So this is actually a little bit off topic. I'm just going to give you a sort of general introduction to Dfinity. With respect to IoT, Dfinity is a wonderful platform. It's a computation platform that is very lightweight to interact with. So it uses some special cryptography that will enable, among other things, IoT devices to interact with it very easily. But Dfinity is a much broader project than that. Can I ask who in the audience has heard of Dfinity? Okay, so better than a year ago or something, right? We're improving. So look, for the benefit of everyone, I'm just going to go through a kind of recap of what Dfinity is and what opportunities it addresses and so on. So, first question, of course, is what is the internet computer? And to understand that, you have to think about what a computer is. And a computer can be described mathematically, right? So people like von Neumann and Alan Turing created mathematical models that described how computers work. And then, of course, people created physical implementations of computers. And that's mostly what we think of when we hear the word computer. We think of a server computer like the one up on the screen, or a laptop, or a smartphone, or something like that. But actually, a computer is defined by how it processes instructions and data, not by its physical form. And you can also create a computer from a network of computers, right? So you can create a single computer from a network of computers. And that's essentially what Dfinity is. Yeah. So you need to kind of understand how this internet computer thing will come into being. Who are going to run all these computers that are going to connect together to make this one internet computer that everyone can install software on and host their data and so on. In the same way that Bitcoin has, or Ethereum has miners that run these puzzles to try and to compete to be the next person to create a block, Dfinity also has miners. It's a different kind of mining, though. It's not based on a competitive process to find the answer to puzzles. A Dfinity mining node looks something like a sort of mid to high-end server machine. And you scale out your mining operations by connecting more mining nodes to the network. And of course, you do this so that you can earn tokens. If you want to imagine who might do this, there are a lot of, for example, private hosting centers around the world, hundreds or thousands of them. And a lot of these private hosting centers have got empty rack space because people have sort of migrated across to Amazon Web Services and Google Cloud and similar services. So, what these private hosting centers can do is install Dfinity mining nodes to make some economic use of their empty rack space. And these independent miners don't have to be coordinated by a central party. They can put the nodes in the empty rack space, connect them to the network, and the protocol does the job of coordinating them. It's fully decentralized. And obviously fault resistant, so the overall network can withstand some of those miners being malicious and sort of playing around with the protocol, or some large number of them going offline. And the nodes join together and produce the internet computer. The Dfinity has long been pursuing scalability. It was founded to pursue scalability. So if you go on the internet Wayback Machine and look at dfinity.io, it's like an old URL, you'll see an early Dfinity web page talking about creating a decentralized cloud from an infinitely scalable blockchain. And we've been pursuing a specific line of design since early 2015. And we want this thing to scale out so it can host the world's software and data. So it's very important that as new nodes join the network, the capacity of the internet computer grows. So you can install more software, run more computations, and store more data. Next question is, what kind of software will run on the internet computer? So, on a PC, you have to run software that, works with the Windows API and typically be compiled down to this format called x86, which runs on Intel, was standard set by Intel. On Ethereum, there's a thing called the EVM, or the Ethereum Virtual Machine. And so when you write a smart contract in Solidity, it compiles down to EVM bytecodes that run on the Ethereum Virtual Machine. On Dfinity, we run a thing called WebAssembly. WebAssembly is a very, very important new standard. It's actually the first open standard for universal software that runs anywhere. It was co-created by a Dfinity staff engineer. And this is going to be absolutely huge, not just in relation to Dfinity, but just generally. So WebAssembly is already supported by all of the major web browsers. So you can create WebAssembly binaries from any programming language that has a compiler that supports WebAssembly. And you can run them today at native speeds inside of all of the major web browsers. So that's a really huge thing. And the next generation of web applications are going to be built using WebAssembly. People are going to be able to create these web applications using any programming language they like, and they're going to run at native speed within the web browser. So of course, it's natural to ask, well, where else can WebAssembly run? Dfinity provides the back-end support for WebAssembly. So if you like, the user experience for systems runs inside web browsers. The client, that's front-end support. Dfinity provides back-end support, sort of rough equivalent to server software. Another question comes up is, where did Dfinity come from? And, of course it is, a decentralized networking technology, and it really can be traced back to Bitcoin, and then through Bitcoin, Ethereum. So Bitcoin was the system that started it all. Dfinity is a very, very different thing to Bitcoin, but Bitcoin was the project that started all of this. And it was the first decentralized network where everybody could share a view of a common state, in this case, a ledger. So Bitcoin's a very simple thing. Everyone can see this 3-column spreadsheet, right? In the first column, you have an address where Bitcoins reside, like a bit like a bank account or something. In the second column, you have a balance of Bitcoins. And in the third column, you have an access control script. And if you can unlock the access control script, you can move the Bitcoins to a new row, to a new address, right? What was revolutionary about this is that everybody in the Bitcoin network can agree on the state of that ledger, right? And previously, there were decentralized networks like BitTorrent, but there was no sort of shared common state. Now, you can search the BitTorrent network to find a file, but nobody has a sort of common view of, like, some common view of a directory of files, for example. It's a very different thing. So Vitalik realized that this concept could be extended and be made much more programmable. And he sort of lent on some of the previous work on smart contracts and created Ethereum. And you can really look at Ethereum as a kind of platform for running tamper-proof software. And in my view, that's what a smart contract is, right? It's software that resides on this kind of sort of tamper-proof platform, and you can be sure that when you interact with that software, you really are interacting with that software, and it will run as it's supposed to and update the data as it's supposed to, right? So Dfinity is really sort of an extension of that. We want to produce something that's much more computer-like and really sort of internet supercomputer that hosts the world's software. And if any of you have been following developments, we demonstrated a system, for example, last October, which produces very, very fast finality. And we have a lot of very talented researchers and engineers working for us. Quite a large team. We've got people in Palo Alto and Zurich and Germany and Tokyo and so on. And this has been under development for quite some time. So what is the purpose of the internet computer? Well, the basic idea is to upload to cyberspace software, data, computation, and money. I say upload to cyberspace because, of course, the internet computer really is a kind of figment of the protocol, right? It's a virtual computer. It looks like a computer. It smells like a computer. You can interact with it over the network. You can install software on it. You can interact with that software. The software will store data on the internet computer. But really, it's a figment of the protocol. It doesn't reside in any one place. The internet computer doesn't have a geography. You can't say the internet computer's in Australia or something like that, right? The internet computer just exists in cyberspace. And it has a bunch of really special properties. And these include things like eternal execution. So the internet computer doesn't have a storage API, right? The idea is you just write software that runs forever. And it's a very kind of different way of thinking about software development than most people are used to. So, in the traditional technology world, you get a database, you get a web server, you get a middleware server, create some microservices. It's completely insecure. You put a firewall around it. And the systems are very complex, tend to be unreliable, certainly very difficult to secure. On the Dfinity internet computer, you just write software and it runs forever. So that's what eternal execution is. Obviously, the internet computer is hack-proof. It's a virtual thing. You can't get a terminal window and try and get a backdoor into the internet computer and get root access and change the password file or something like that. It's just not possible. You can create autonomous software. So this, we think, is going to have a lot of potential in the open sourcing of businesses. So you can recreate internet services that are really open source businesses. So you can create an internet service which is tokenized, has a governance system built into it, where the token holders control the governance system and can use that to update the software, right? They can issue bug bounties and things like that. But there's no organization behind it, right? So we think autonomous software is going to be huge. Obviously, eternal execution provides for a much simpler and lower cost R&D model. So we think it's going to be much less expensive to develop software systems on the internet computer compared with the traditional technology stack. And finally, it can provide privacy guarantees. So you can create kind of crypto lockboxes using things like enclave technology that keep data private, even though that it's a public computer and you don't know who's running the mining nodes. You can upload software, and when you do it, configure it so that the data is kept private. And you can even use autonomous software to create data repositories to which nobody can ever have access. The data exists inside the repository, but no human can gain access to it, although you can run algorithms on it and so on. So it's worth thinking about what are the different sectors that the internet computer can be applied in. There are 4 main sectors. The first is private software systems. So it's funny how far blockchains come, but Dfinity sees itself as an alternative to the traditional technology stack. So, we want to provide people with a way to create, e-commerce systems, HR systems, order tracking systems, all the kind of systems that businesses think about creating. And the proposition to them is, well, you know what, the computation and the storage, the per cycle of computation and per megabyte of storage, it's more expensive because behind the scenes, of course, the internet computer is doing all this cryptography and it's replicating data a large number of times to make sure it never gets lost and so on. But we greatly simplify R&D. And actually, most of the cost in software systems and IT infrastructure is human capital, or human costs, cost of developers and the guys that are administering and maintaining it and so on. So we can dramatically reduce those costs. And then, of course, once you've created the system, you have other benefits. It's on a hack-proof platform, so it's much more secure, much more reliable. It never, eternal execution. It never loses the data. It just runs forever. And you have ways of preserving the privacy of your data. So the next one is decentralized business infrastructures. So a lot of industries are looking at creating shared platforms that optimize one thing or another. So supply chain is a well-known application, and there's already a number of industries are already creating these kind of systems where the movement of goods and services is tracked, and they can invite people in to finance invoices to release liquidity from the supply chain and so on. The challenge that has existed in the past with respect to creating these kind of systems is that if you went to a big industry and said, look, I'm a startup, I'm going to create this platform which you can all share, right? Nobody would listen to you because they'd be thinking, hey, hang on, you mean we're all gonna rely on this platform that you're providing to us, and we'll be giving you enormous power. There's just no way we can possibly do that, right? And secondly, of course, with traditional technology, it'd be very difficult to make that kind of platform secure and reliable to the degree that would be necessary, right? So, internet computer technology can solve that because you can use autonomous software to create an open software platform that has an inbuilt governance system, which is perhaps tokenized, and you can, all kinds of variations are possible. You can have like a Swiss association, right, where your voting power in the association matches the number of tokens you've got, and ultimately that's used to determine what software updates to incorporate and things like that. So you can solve that problem with internet computer technology using autonomous software and create an open platform for an industry to share, and participants don't have to worry about giving away power to some private company that might behave in unexpected ways in the future. And of course, it's much more straightforward to create a reliable, secure system. The third sector is decentralized internet services. So this is a particularly interesting one. Again, using typically autonomous software, you can reinvent internet services as open source businesses. What that means is, there isn't a company or organization of any form behind these services, right? The services will be tokenized. They'll be implemented using autonomous software, and there'll be an inbuilt governance system that makes it possible to adopt software updates, right? So that, I think, will provide a kind of mutualized network effects to people building on the internet computer, because one of the challenges that all startups face is something called platform risk. So an example of that would be Zynga. So Zynga created that very famous social game on Facebook called Farmville, and they were growing very rapidly, and I think they IPO'd and they were worth $5 billion or something. And then Facebook decided that they wanted to change the rules that social games companies used to promote themselves on the platform. And pretty much overnight, the rug was pulled from underneath Zynga, right? And they were no longer the force they were before. And that's actually a very common thing in Silicon Valley. We see that kind of thing happening all the time. It's called platform risk. When internet services are reinvented as open source businesses, using autonomous software, they can provide much better guarantees about the APIs that they provide to other systems. So, innovators and entrepreneurs will see this, and they'll realize that if they build on this more open ecosystem, there's much less chance that the rug will be pulled from under them. There's also things like dating apps where people forget all of these potentially embarrassing information is stored on these central servers that can easily be hacked and have the information leaked onto the internet. So you can combine usage guarantees provided by autonomous software with crypto lockboxes that ensure that, for example, in the case of an internet dating app, that potentially embarrassing chat information doesn't come out into the public domain through a hack. And the really interesting thing about this sort of lockbox technology is you can, although the data is safe inside, no human being, it can be designed so no human being can ever get the data, you can still run algorithms inside the crypto lockbox. So you can have algorithms that run looking at the chats, looking for keywords, and so they can match people better. But nonetheless, no human being can ever retrieve that information, that embarrassing information. Final sector is, of course, decentralized financial systems. Dfinity isn't designed to be a platform for ICOs, but no doubt that'll take place. I think we're going to see the emergence of, potentially, mass market borrowing and lending systems, prediction markets, insurance, token exchanges, that kind of thing. So, large number of uses. Next question, how is the network controlled? So we've seen a lot of problems relating to governance, and there are a lot of different views. There are certainly some merits to the code is law approach, but we believe that you need to have a very far-reaching governance mechanism running on the network. And you can read about this online if you're interested. We use a thing called the blockchain nervous system. And very simply, it involves people creating what we call neurons by staking Dfinities. Once you've created a neuron, you can't get the Dfinities back without dissolving the neuron, which takes a year. The neuron participates in voting. The voting power of the neuron is proportional to the number of Dfinities locked inside of it. You get rewarded for voting. But of course, voting can be a tiresome thing. You have all these proposals coming in with different topics like economics, cryptography, and so on. So what you can do is you can configure your neuron to vote automatically. It's actually run from your smartphone or a laptop. And you can configure your neuron to vote automatically. So, you can say, on cryptography, I don't know anything about cryptography, so when a proposal comes in with a cryptography topic, tag, I want to follow these 5 neurons. And you have the addresses of these neurons. People have advertised them on their Twitter profiles and Reddit posts and things. I want to follow these 5 neurons. If 3 of these neurons vote adopt. If 3 of them vote reject. If neither of these things happen after a timeout, reject, right? And this blockchain nervous system has sort of privileged software running on the internet computer that can, reach into the internals of the network. It can, change the economics. It can manage network structure. It can upgrade the protocol. But it can also do things like freeze miscreant software systems that the internet computer is hosting. So let's say, people became aware of an ISIS slave market running on the internet computer. Someone could put a proposal in. This is a nefarious thing. Freeze it. And if that proposal goes through, the blockchain nervous system can freeze a nefarious system. The scope of the blockchain nervous system hasn't been fully decided, but it would also be the case. It would also be possible to, for example, have software inside of these crypto lockboxes that is blockchain nervous system aware. So if the blockchain nervous system says de-anonymize this software system's data, the special software inside of the crypto lockboxes could actually export that data, perhaps encrypted to the public key of some law enforcement body. So in that case, the blockchain nervous system will become a kind of ethics committee, deciding what a nefarious system is, or who should have their anonymity or private data exported. So finally, who is pursuing this? Dfinity is actually a not-for-profit foundation that pursues scientific research, engineering, and when the network's up and running, threat mitigation and network support. So we've got quite a big presence in Switzerland. We've got some people here in Zurich, Neuchâtel, Lucerne. We've got a big research base in Palo Alto in California, so I spend a lot of my time. People in Cambridge, Tokyo. And it's we have a sort of slightly different mentality. We believe that if we're going to create an internet computer that's going to support the world's software, run the world's software, there needs to be a commensurate organization standing behind that network, right? And so we've got this kind of concept, we call it a bit of a silly name, like NASA for decentralization, but we're building out, kind of very large and competent organization. I say very large, I mean, not in terms of technology giants, but in the crypto world. So, we envisage that when the internet computer's running at scale, the Dfinity Foundation will employ hundreds of people. And, we've been lucky. We've managed to, recruit some very talented and senior engineers and researchers. So, it's on the Dfinity website if you're interested. But, if you're interested in working for Dfinity, go and check out the Dfinity jobs page. So, lastly, anyway, this is me. This is a little video. I took it 3 weeks ago in Palo Alto. It's the Dfinity test network with 400-odd computers distributed around the world. And I don't know if any of you actually follow the tech, but there's this thing called threshold relay and the probabilistic slot consensus. And the nodes which are flashing green, the current threshold group, which is sort of collaborating to produce the next random number, which sort of drives the whole protocol suite. Anyway, I think that's it for me. Yeah, thanks.